Thank you. Okay, so our product and engineering team recently surveyed our Fortune 1000 customers and determined that over 90% of new Gen AI initiatives ended up either being too hard, be too slow, or either too costly because which are vast majority of the enterprise data is stuck in an iceberg-like situation, or it's structured in a way that the hype around vectors doesn't exactly work. So come join us on June 26th. Our engineering team is launching new product features that will enable companies to build enterprise-grade Gen AI apps on Iceberg data. You can think data on Snowflake, Databricks, Azure Data Lake, etc. that can get milliseconds of response times. So sign up right now. The link is present on your screen, and I will also put it in the chat. So join us with the real-time AI revolution. Okay. So moving forward, allow me to announce our amazing speaker today. We have the real database expert today. Joining us today is Vinija, who is an AI leader at Amazon. We're very happy to have you here as our speaker today, Vinija. Welcome. The floor is now yours. Please, let's get started.
Awesome. Thank you. Thank you so much, Yukti, for that handoff. And thanks everyone for being here. So to start off, I just wanted to start talking about SingleStore's database for a minute, and we'll also talk about the free tier, and then we'll get into today's topic. So SingleStore's database, why it's better, why it outperforms the other databases on the market. There's a few reasons. Like it runs real time, it's distributed, it runs SQL, it's a vector database as well. It's unified one table type transaction and analytics, and has universal storage. And I'll kind of show you what I mean with this visual right here. So a quick visual to support what I just talked about here. SingleStore is capable of supporting both analytics and transaction level workloads in the same system. This is made possible by their patented storage engine built into the product. Regardless of the data source, they support ultra-fast ingest of data in a variety of formats with a single cloud product, but many different options. They have full managed databases offered in Azure, GCP, AWS, and self-managed offerings for any cloud, on-prem, bare metal, VM, whatever makes most sense for your business. So would definitely recommend trying them out. And as for the free tier allows you to try out their notebooks, their database, their monitoring, all in one place. So you can try out the whole product before actually committing. And if you go to the previous webinars, all of them have been done from the SingleStore's free tier. So I definitely recommend checking that out. All right, on to today's topic. So today, what we're interested in talking about is how to build secure AI health applications. And to that end, I've kind of divided this talk into 3 different sections. First, we'll motivate what is the need for AI in healthcare. Then we'll talk about how security is done in terms of patient application, patient data, traditionally. And then we're also going to talk about AWS Private Cloud and how you can deploy your application on AWS Private Cloud and how they manage all of that security for you. And lastly, we have a nice demo here, and the code and everything will be shared with you offline. So yeah, let's get started. Building a secure health application. So let's start with the motivation for how AI is used in healthcare. There's definitely many use cases here. There's diagnosing the, sorry about that, diagnose the imaging, treatment personalization, virtual health assistance, predictive analytics for patient outcomes, robotics and surgery, drug discovery, research. There's so many different options. You can also think of it as a chat application where you can have kind of a LLM just conversing with the patient online and having 24/7 healthcare support rather than having someone actually sit there and talk to you. So virtual health assistant providing symptom information, treatment guidance, post-care support, any appointment information, treatment personalization, so AI tailoring treatment plans using larger databases to help your customers. There's predictive analytics, AI predicting the patient's outcome and identifying any risk levels, personalized treatment options as well with their history, AI can better understand any allergies, any information that can customize their treatment processes moving forward. I also wanted to talk about a few research, and actually specifically research by me and my collaborators that we have in the field here as well. I'd recommend you go check that out. The first one is MedSum here. So what MedSum is looking to do, it's actually looking to take the patient's queries. What we're trying to do here is sometimes in non-English speaking worlds, there could be a code mixed languages. So there could be Hindi mixed with English as the patient's query, as well as the image provided of their illness. Right now, I blocked this out, but if you go to the paper, you can see all of the different information and data sets with their disclaimer there. But I blocked out the current image and with the code mix text. And what it does is the MedSum model that we created here is multimodal. It takes in both the image as well as the text in different languages, and it's looking to summarize that text into a logical format, into trying to pull out the important information and extract all the important details from both of these modalities and form it in such a way that the doctor is able to understand and easily respond. What this allows us to do is to be able to bridge that gap of communication between the patient and the doctor, and to be able to get to the diagnosis and the care more quickly and efficiently. And here's the link. Feel free to check it out offline. There's another research that we're working on. We actually just submitted this to EMNLP 2 days ago. It's called M3 Help, Multimodal Multilingual Medical Help Assistant. So what this project is looking to do is it's looking to work as a helping assistant to doctors, and it takes in images as well as text as well. And what it's looking to do is help diagnose, but not essentially diagnose, but work as an assistant to the doctor and sort of give different treatment options and ideas so that the doctor can then leverage that information and proceed to better care and just have an assistant along with them, a virtual assistant in a way. And the data here was verified by real doctors. This paper is coming out soon, so I definitely recommend go checking it out as well. Yeah, so back to SingleStore's database as well, really quickly. Wanted to talk about how it works in a different ways. As you can see here, you're able to do both vector, they have vector types as well as file types. And the vector type here, the similarity score is the dot product that's used, and it's defined by this asterisk. So you're able to run similarity score on the vector database right within the query itself. Here, what they're looking to do is select the file name, the vector as type score, from people, and order it by the score in descending order, limit by 5. And of course, the way it's looking to order is it's scoring with the dot product in descending order and limiting to 5. So you can see you have your vector database and your similarity search all built in one in this very simple and easy to use query as well. I definitely recommend you check that out and let us know what you thought about it. So now let's also talk about the privacy aspect here. We saw how AI can be used in healthcare, just a few different ways. There's a lot more applications here, but a few different ways we saw how healthcare can be used. The most important question here is, of course, privacy, and how do we keep our customers' information private and secure? So one of the ways we look to keep the customer's information private is on-device privacy. So what on-device privacy does is it processes the data on a user's device and not on a central server. So you can think of it as your smartphone, your tablet, any device. The data is actually being processed on your device itself locally. So this increases privacy and security by keeping the data local and reducing the exposure risks. for any large language model tasks or any tasks in NLP in general, all interactions and responses will occur locally, which is crucial for that private conversation. It reduces latency and improves user experience, but it does come with a challenge of running resource-intensive models on devices with limited capacity. So say your device is even smaller, say you're looking at a watch here, an Apple Watch. Now you're limited in terms of capacity, but you still want to run your model. There's a few ways to get around that. You can run a few model compression techniques like pruning, quantization, to enable even smaller models to run on these devices. But if that's not an option, then we have a few other privacy options that you can choose. So this is having your data run locally within your device. Now let's talk about differential privacy as well. Differential privacy quantifies the individual privacy in the data set by adding random noise to it. So you can kind of see this visual here. You'll have your original data. It will synthesize the original data by adding a little bit of noise to it and then generate synthetic data and then get to your output. So the reason to add this noise is it makes it difficult to identify individuals while preserving the overall data pattern here. So the noise here is really trying to kind of disambiguate the user's information from their results and from their information, from their medical history, so that we can come to the conclusion easier. So for example, it prevents the model trained on medical records from generating text traceable to a specific patient. And implementing differential privacy in LLMs is quite challenging. It requires a balance between the noise and the model's utility. So you really need to play around with how much noise you can put in without losing the integrity of the model itself. And the third option we have here is federated learning. So federated learning trains the model across multiple devices, keeping data localized. And each device here updates a local model periodically combined into a global model without the raw data leaving the device. In NLP, in any AI applications, conversational AI applications, this method enables learning from the diverse data sources while maintaining the privacy. So a quick example here is a conversational AI learning from interactions of many devices and understanding various contexts and dialects without accessing the raw conversational data itself. So you can see kind of this structure here. The server here contains the global AI model, and it coordinates the training of that global AI model. And then it takes that global AI model and it serves to different local devices that all can live in your smartphone or whatever device you're using to run this application. And you have kind of a snapshot of that application within your own devices here. So you're able to run this model locally for yourself. So just to quickly go back and talk about all of these different options and how you can use them within healthcare applications. So with on-device privacy, the user's information, especially in healthcare, it's on their phone itself. So their information is never leaving their device. And this is very secure, very private. All of their detailed information exists right within their device itself. Of course, it comes with the challenge that the model needs to be as complex as that device can handle. Then differential privacy, what this would do is it would add noise to the user's data. So any users you have coming in, any diagnosis they have, any treatment plans they have, it will add noises to their data and then come to results. Of course, again, you have to play around with the noise and see what the trade-off between privacy and the best output from the model, and finding that kind of harmonic mean between those two options is something that you'll have to figure out empirically and see what works best. And the third option, the federated learning option, you'll have just a server with the global model, and then it'll run the main model, and it'll send the snapshot of its model to all of these local devices. And what these local devices will do is they'll keep coordinating with the global AI model to make sure that there's no data drift happening, make sure that the global AI model is also in sync with all of the data that's coming in, but it's only looking to share the kind of model, not necessarily all of the key informational data that it holds. So those are the three privacy preserving methods that are generally looked at. Now what I wanted to talk about was AWS Private Cloud and how it can help your applications run so you don't have to go around and implement all of these methods on your own, and you can get up and running as quickly as possible. And we'll go to this link as well and just look at how AWS Private Cloud runs its applications and how deployment is done. So first, quickly, let's motivate what AWS Private Cloud is, how it works, and all of the amazing qualities that it has to offer here. So understanding the AWS Private Cloud. The AWS Private Cloud is a managed private cloud infrastructure provided by AWS. So you can kind of see this graphic that they've presented here where you will have your own network here. You'll access their infrastructure via the secure VPN connection over the internet. And they have all of the EC2 instances, routers, the web server, the web services cloud, the customer's isolated AWS resources, subnets, all of this information that they will securely manage for you, so you don't have to deal with any of the implementation criterias for privacy for your users. The different types of private cloud solution it offers on-premise private cloud, which means you can deploy on the organization's own hardware and data centers. It also manages private cloud, so managed by a third-party provider, but dedicated to a single organization. It also does VPC, virtual private cloud, which is deployed within a public cloud infrastructure, but isolated for private use. And what this whole orchestration is, it's an isolated resource and user control, and it's accessible through a self-service portal for flexible management here. If you've ever run any AWS application, the general portal for all of them in the backend are very similar. You onboard with your user profiles, your restrictions, and the portal allows you access to different resources, whether it's adding different environments, whether it's adding monitoring with CloudWatch, whether you're trying to run an EC2, a Lambda function, whatever you have, it's all the same portal in the backend, so it makes it very easy to manage and then to deploy your application. And a few quick benefits, and actually kind of wanted to emphasize the privacy and security that AWS Private Cloud provides for your users here, especially for healthcare. So what AWS Private Cloud is able to provide is encryption. And what I mean by encryption here is that data at rest, the data is encrypted to protect from unauthorized access while it's being stored. So you'll have your data stored in S3 buckets. In DynamoDB, it's all encrypted there to protect it from unauthorized access. Even the data in transit. So if you're now having an application using that data and it's in transit, even that is encrypted to ensure security during the transfer between the systems. You also have access control. So you have IAM management roles, And what these roles have are fine-grained control over who can access resources and their actions. And these roles are customizable. You can give someone just read access, read and write access, whatever different fine-grained access you want to give to those users is something you can define in the IAM policy to make sure that the user who's coming in accessing your system is only able to perform the different operations that you have approved of, which also then helps the security in that sense. You also have multi-factor authentication here. So it requires multiple forms of verification for added security to be able to even log into your system and your portal. So that's accessing all of the control for your data and for your patient's data and records. There's compliance, which is very important for healthcare. There's HIPAA, which protects healthcare data according to stringent privacy standards, and AWS Private Cloud is able to support HIPAA application and HIPAA data as well. There's GDPR, which ensures personal data protection for users in the European Union. And then there's ISO 27001, which adheres to International Information Security Management Standards. So AWS Private Cloud is able to follow all of the different requirements, whether it's just HIPAA, GDPR, or the even international standards in terms of how to protect your data and how to keep it safe. There's network security here as well. So there's virtual private cloud creates isolated network environments with advanced security features. So all of this is kept within their own infrastructure itself. So you're not having to manage any of it by yourself. You're not having to manage each of the different informations here. The security group and network ACL, it controls the inbound and outbound traffic within the VPC. And then the VPNs here create that secure connection between the on-premise network and the AWS resources. And just to quickly go back, here's the VPN network that we saw earlier. And this is how you're able to connect from your own network into all of the information that you have given to the private cloud here. It also, I touched on this earlier, it offers monitoring and logging. So there's AWS CloudTrail, which tracks a user's activity, API usage for auditing, compliance. This is very important to monitor to make sure your application is working right. There's no one trying to break into your applications. You're able to see where the API calls are coming from, how many times you're being hit. All of this information is really important when you're dealing with such secure and highly sensitive data. And of course, there's Amazon CloudWatch, which is a monitoring system. It has metrics. It has application logs for real-time visibility and alerting. It's able to set alarms. So if anything, it goes off, you can immediately go into your application and look into what's going on, shut down pieces of the application, or just look into debugging it as quickly as possible. And lastly, the most important source here is data backup and recovery. So not only is it important to think about the privacy of your data while you're being used or while it's in rest, but also as you're having it back up and in recovery mode. So AWS backup, what it does is it automates and manages the backup to ensure data integrity and availability. And it also offers disaster recovery plans to make sure that businesses' continuity and their data recovery in the case of catastrophic events is not limited and the data is available to be recovered there. So this is a lot of information that I've shared with you here, but all of this is very important when you're looking to choose a private cloud option, especially when you're looking at a highly sensitive and really important and private information for your users. And nothing could be more private here than the healthcare use case. So AWS Private Cloud is able to offer you encryption both with data at rest, data in transit. They're able to offer you access control, different users coming to your application with different IAM roles and adding different policies to it to be able to give a fine-grained control. It has compliances with HIPAA, GDPR, network security, of course, with VPC, VPNs, monitoring and logging, data backup and recovery. And all of this has very detailed documentation available online on their website that you can access and you can just make use of to help you get started. All it really requires you to do is have an AWS login, log into the portal, have your application deployed there, and just get started to use. So actually just the next topic I was going to touch on here is the steps to deploy to the AWS private cloud. Now you've seen its benefits. How do you actually access it and how do you actually use it? So it's as simple as that. You just create an AWS account on the sign up page. You assign your correct administrative access to the users after the account is created. And you can manage your AWS account under the My Account tab on the portal. You can verify permissions, so refer to the IAM documentations that I mentioned earlier. So what it will do is you can create different policies, and then when you create the new role, you attach those policies to it. So you don't need to have just read only, write only. Maybe you want a specific user to be able to only see a certain table within your database. You can customize this role to be anything that you need under the sun and have that attached to this, call that role something very specific, view table only, and then assign it to the customers that you want to be able to only view that specific data information and nothing more. Perhaps it's a different hospital, perhaps it's a patient with a child and they should be able to view their data as well as their child's data. So you can customize all of that within the permissions itself and within the role itself. Determining the IP address ranges, you can choose the IP to address ranges within your VPC, select the availability zones for your research deployment, use at least 2 zones for production for fault tolerance, and plan your internet connectivity. So plan your subnets based on connectivity needs, create your VPC, use your AWS management console to create your VPC. AWS configures and routes these tables and internet access for public subnets as well. And then lastly, once you've had all of this set up to deploy your application, all you have to do is say you want a production environment here. Use services like EC2 auto scaling, EC2 fleet, or Amazon ECS across multiple zones, have a development or testing environment as well, and launch a single EC2 instance as needed. You can have continuous deployments, you can have your monitoring happening alongside it. So it's an end-to-end platform system, all living in one portal for you, and it ensures privacy for your data, encryption for your data. So it's a great one-stop solution for your application and for all of your needs. And what we're going to look into today is a healthcare demo for diabetes risk assessment. Actually, it's a predictive model here, and this also looks at having very sensitive data for the users. Once this application is created, all I would have to do is sign up here for an AWS account, verify permissions, and then have my application deployed into AWS, make my different environments, and have it up and running in production. Yeah, so now let's switch over to the model details and what we're going to be looking at in the demo today. So this is a quick sneak preview of what we're going to be looking at today. This is a diabetes risk prediction model, as I had mentioned. What it's running in the back end here is a simplistic model here. It's running logistic regression in this script to predict kind of that binary risk based on health-related features. So the different features I have here is age, BMI, blood pressure, cholesterol, sugar levels, thyroid hormone, all of this different information to be able to then predict just in a binary sense, 0, no risk, 1 risk classification here. The code will be shared with you after the webinar, and I would urge you to kind of change the model in the back end, maybe use different maybe ensemble methods, maybe you can even look at deep neural network methods and see how it performs in the back end and how the kind of the risk assessment changes there itself. So yeah, definitely. And with that, let's get into the demo here. So I'm gonna switch over to the our risk prediction application. Let me know if you can't see my screen, but this is what we're running here locally. We've deployed it here locally. This is the quick demo that I ran earlier, where I had the age set to 55, the BMI to 22, blood pressure, the blood sugar levels, and I ran prediction, and it was able to see that the risk level was 1. Now, let's try with, say, someone a lot younger. Maybe let's just keep it at 15 with the same information. So we're able to see that with 15 and the same health accesses that we have earlier, the risk level is now a lot lower. So age is definitely a big factor in terms of predicting the risk of diabetes happening. Let's try one more. Let's say maybe 100 with the same information here. As expected, the risk level is, of course, on the higher end here with all of these information, and we can try changing a few other things here. Maybe let's go to 25. BMI, let's make it 20. Sugar level 95. And let's assess the risk assessment here as well. The risk here is 0. So that's great to know here. And so Yukti will share the GitHub link with you offline, but just to quickly show you what this is looking to do here, it's just, if you want to set it up locally, you'll just have to clone the repository, create your environment, and then train your model and run the train model.py file. And then this is a Flask application on the front end. We'll look at the code as well, so you're able to understand what it's doing in the back end. And then once you have all of that running and set up, you should be able to have the application running, and you should be able to test it out on your own. And I'd love to see the different results you're able to get from changing the models, changing the UI, changing the different information, perhaps the adding in more, maybe there's something else that could be a criteria. There's a weight isn't listed here. Perhaps you can kind of leverage that and see how that changes the risk assessment here. Now also let's switch over and look at the code here as well. So it's a very easy to understand code in the back end here, but I'm going to focus here on the main files. One of the main files here is the train model. Then you have your application, app.py, which is running as the backend of the UI interface, and it's kind of connecting the models trained assessments here with the front end, which is on our index.html. So now this is just traditional HTML to make the UI appear the way it does in that format and give it the pop-up notification with the results that we have. I would say that you can try out different ways. Maybe you can make it interactive. Maybe you can even actually put an LLM on the back end and see how it works. But what I have is a simple application here. And then the model, as I had mentioned, is using logistic regression. We're using scikit-learn and pandas libraries here to run all of our application. And we have logistic regression here. In terms of the data, we're using simplistic data and we're putting it into the data frame. So we have the age, we have BMI, blood pressure, everything you saw, as well as the risk assessment that we're determining from this data. We have even more data that we've generated synthetically in the backend, and I have the script for that as well. You can look to leverage any current data sets available on Hugging Face and see how that works as well. So all we're looking to do here is we're splitting the data between the train, test, distribution, and that's all that's happening here. And then we're looking to standardize the features, scaling them, transforming them. Then we're looking to actually train our model, just do model.fit, train it on the scale data that we have. And then what we're looking to do is just kind of dump the models and the scalar and have it saved into the file here. Now, once we have this model trained, we have the app.py here that's looking to route the prediction, and it's looking to do all of the routing from the take the information from our front end application, route it here into the kind of almost middle layer, and then go into our backend application here with the model train. So that's the overall structure here. You can see it's running all of the log outputs. It's determining as I'm running it on the UI and all of the different information I'm able to see. And when you run it, it's basically just giving you the information on where you can see it run locally. So definitely go ahead and play around with this and let me know what you think. Yeah, and with that, I will hand the mic back over to you, Yukti.
Hi, thank you. That was really cool. So we can actually start with the Q&A session. We have a lot of questions. So we have one question from Masood. They say that, can you please send the AWS deployment link? Is that possible for you?
Yes, absolutely. I can add it to the chat right here.
All right. Just make sure you send it to everyone. Like, never mind. So I'll just take care of that. So I hope that answers your question. Moving on, we have one question. We have a couple of questions from George. They say without any ML, the prognostic of this case is obviously zero. I think it's more of a comment. And then the follow-up question is, what is the degree of ground truth of the data with which the algorithm was trained?
Yeah, absolutely. So that's a great question. This is our little test model to be able to show you what is possible here. I would say that, if you're looking for extreme accuracy, I would say definitely more information than just these would be needed in terms of determining your diabetes risk. I mean, you can talk to healthcare professionals and really understand all of that information. Just in terms of our use case here, we're keeping it simplistic to just understand whether there's a risk or whether there isn't a risk. And this is a prediction on whether there is a risk and there isn't. And in terms of and even intuitively, if you have a higher age, higher levels of cholesterol, higher levels of blood sugar, you would tend towards higher risk for diabetes. And that's the kind of intuition we looked at when determining the data here and looking at informing our prediction model. Now, would I use this in order to diagnose myself? Probably not. I'm not a healthcare professional. I would actually, if that's something that you're looking to do, I would look at maybe even getting more sensitive data, talking to different healthcare professionals, understanding the different requirements needed to determine the risk for diabetes, and then adding that within the application. And that can take, and in fact, even getting a more complex model. So not just determining a binary risk 0 or 1, but more nuanced risk assessment as well there. So in terms of accuracy, I would say this is not to say the most accurate. This is for our demo reasons here, but yeah, I would urge you to go ahead and see if there's any other data information, if you're able to chat with healthcare professionals and see what else you can get out of this in terms of risk prediction.
So we have a question from Daniel Wong. It's more like a comment, like you can just let me know. So they say that it is not using SingleStore or even AWS Cloud as a database. So I think we used something in the back end, right? So just can you please explain here?
Yeah. So what we are looking to do here is right now, this information can be deployed to the AWS Private Cloud. So that's what I was explaining here in our prior slides, right? Once you have your application like this built, there's very few easy steps to have your application launched onto the private cloud and have it up and running. You can also, of course, have this information saved and stored for your users within your SingleStore databases as well. For our use case here, we're looking at a risk prediction assessment. So this application is looking to do just a risk prediction. It's not looking to hold users' data. It's not looking to kind of run in a production grade environment, kind of giving you a glimpse as to what is possible in terms of a healthcare application. So that's kind of the motive we're coming for. But yes, once you have an application like this, once you have a large scale organization, you can have all of the users' information being stored into the SingleStore databases, whether they do both SQL as well as vector databases. And then you can also have it productionally deployed with the AWS Private Cloud. Yeah.
All right. So we have one question from Sudarshana B. They say that, is it necessary to download any prerequisite softwares to deploy this in our system? So like after cloning the repository.
Yeah, that's a great question. So what you'll need to do is just make sure all of the libraries are ready and available on your local system, and then it should be up and running. And you'll be able to actually just check when you're actually trying to run the model, or if you're trying to run the app.py file, it'll just tell you in the logs if, say, you don't have scikit-learn or whatever library not installed in your application, and you just would need to install that. But otherwise, it's easy to get up and running with this application. That's the other reason why we kind of chose for the simplistic model. So it was able to be tested by multiple users here in the webinar easily and have it up and running. But feel free, if you're running into any issues, to message me offline as well.
That's very kind of you. So, everyone, I see some couple of hands raised. Just a small note that the Q&A button is at the bottom of your console. Please feel free to use that because we don't take questions that way. So moving on, we have one question from Mark. They say that for the US market, what does the CMS say about using AI? What's allowed and what is restricted? What is your comment on this?
Yeah, so in terms of, I think they're hitting towards data privacy. So in terms of data privacy, I believe in the US we have HIPAA. And in terms of understanding what you can keep with the patient records, HIPAA compliance actually details out very specifically how you can store patient records, how you can store any other medical informations, and the database actually looks to have that information stored according to their compliance. So as far as I know, in terms of the US, that's what we use. But in Europe, they have GDPR and international codes as well. But in terms of US, there is HIPAA compliance, and without HIPAA compliance, you can't actually even launch your application within the healthcare domain. Whether even if you're not just core healthcare, even if, say, you're an insurance company that has some patient records just for filing claims, anything that looks to deal with patient data and patient records needs to follow the HIPAA compliance there.
Right. So, there is one question from Gabriel. They say that how does the private cloud differentiate with public cloud AWS that AWS is offering?
Yeah, definitely. That's a great question here. So what private cloud is able to do is, first of all, it gives you this secure VPN connection over the internet. I'm not sure if the public cloud specifically provides that, but this is one of the key offerings of the private cloud itself. Also, it's the other big offering here is the customer's isolated AWS resources. So it's able to isolate all of your AWS resources in order to better be able to kind of create and manage the cloud infrastructure in the private sense, in an isolated resource, in an isolated sense, to be able to have more user control and make it more accessible through the self-service portal. It also allows you to have better and more flexible management. And the other biggest offering here is it has on-premise private cloud. So you can just actually have it deployed in your own organization's hardware and your own organization's data center, but it will be managed by the private cloud itself. So the managed by a third-party provider, but dedicated to the single organization here. And then the last offering that they had was VPC deployed within a private cloud infrastructure, but isolated for private users as well. So all of these offerings itself, and along with that, they will also follow any HIPAA compliance, any other data compliance that you need for your specific data here, and then manage it that all within one ecosystem, which makes it very easy for you just to focus on your application, and then have once it's deployed, have it all sent over and have it all be able to visually be seen on the portal itself, monitoring, logging, API calls, everything all in one portal itself.
That sounds very convenient. So, moving on, we have one more question from Bhavna. She says that could you share more information about how you validate the model? Is it returning the right prediction results?
Yeah, absolutely. So when I was running this, there's different actually versions of this model that I run it. Earlier, I have evaluated this model across with accuracy, F1 score, and and precision, I believe. So I've used quite a few metrics when I was running this model in its prior versions, and I was just testing it against the ground truth and making sure that the labels that I was testing with the different values that I was putting into my form there were correlating with the ground truth. And also, of course, having the evaluation metrics. So that's kind of how I look to test it. Again, the data that I have here is just looking at the age, the cholesterol sugar levels here. So it was not as complex to do in terms of evaluation, and also the kind of A/B testing, which I did once it was launched online, and making sure as I put in the different information, it's able to give me the same ground truth result with the label 0 or 1. I would definitely urge you to try and just push it one step further and add in more information, and even change it from the baseline model here, which is logistic regression, and actually compare the next version of the model that you use against this baseline version and see how it's performing, to also add that within your evaluation. So have your evaluation metrics, have the baseline comparison with this, and then run your A/B testing as well. Yeah.
We have one more question from George. They say, what is the level of interoperability with EHC?
EHC?
Yeah, I am not sure. If
If you're
you're
able,
still there, you can write it in the questions and like just to elaborate. We can move on to the next question. If this does not really ring a bell, it's totally fine. So there is rather, I would say it's a comment from Mark. Would you please post the Midsum link?
oh, sure, definitely. I can share that with you offline too, Yukti, if you like.
Right. Absolutely. So we'll include that in the follow-up emails. All the sources that are relevant with this webinar will be shared with everyone. So do not worry. I see many questions regarding that. So that's going to be taken care of. And so I have one question from Fury. She says that so an organization does not have to deal with HIPAA compliance at all if their application is deployed in private cloud. What, like, do you think that's the case?
No, sorry if that's how it came off. No, definitely not. HIPAA compliance is required if you have patient data. It doesn't matter. The reason for you having patient data and the reason for your business needing it, even if, say, you're not a hospital and you're looking to have patient data for maybe you are a healthcare startup, maybe you're an insurance company, you have patient data. If you have that, you need to follow HIPAA compliance. It is on both you and as well as the place where you're looking to store your data to both follow HIPAA compliance. And actually, if you're interested in knowing, there's a whole process that goes on. You have to go through a kind of an education where you have to understand what HIPAA requires. You have to fill out a form, you have to agree to having it, then you have to make sure that your data is stored with compliance to HIPAA regulations. And then it's on you to also make sure that any services you're using are also doing the same. So that end to end, you have to make sure that you are HIPAA compliant whenever you're dealing with patient records and data.
All right. So, I mean, that comes off as like patient data already, it's like very sensitive.
Yeah.
So, I mean, there's one question related to vector databases. So what we used to do during my research, we used to convert CT image or MRI images, like it's a 3D image, right? So 2D images are there. We used to convert it into vectors and then feed into a model and then train that thing. So I think
Ah.
it can be related to that. So can you feed data set into a vector database and use this piece of software communicating with the vector database? Does it support working with any vector databases? So I think you can just answer this question in context with SingleStore if you can.
Yeah, absolutely. So yes, absolutely you can use SingleStore's vector database. And this is the slide right here to with this information. And you brought a great point here for images. You can also have text here as well. So any of the user's information with text here, and then as you're looking to do a search, you can just do a search for all the users or any other information within your vector database. And what it'll do is it'll do the closest match. This is just dot product, but I'm pretty sure SingleStore has capabilities of other similarity searches as well. Anything that you need for your application, and all that's looking to do is the algorithm on the back end is looking to find any of the different kind of or files or different data sets that are closely related with what you're searching for here. And it's going to give it a score so you understand how closely related it is to what you're looking for. And it'll, of course, you can, like any traditional database, limit it by 5, order it in descending order. It offers you all of this flexibility, and the query writing process is very simple, very easy to use. I would actually suggest you sign up for the free tier and give it a whirl. Just run it there and just see how easy it is to just have your data stored here and access it. Yeah.
All right. So I think we just have 4 minutes left. We can just take one more question and I'll just pick one up. So we have a lot of questions actually. Just give me a second.
Mhm.
So we have like one question from Vesaki. Should we run our models only with Python language or our programming language can be used as well?
It's up to you. The SingleStore database, or if you're looking to understand if leveraging SingleStore is kind of language agnostic, it definitely is. You're not kind of limited to using a specific language for your application. If Python is not your language of choice, feel free to use whatever you like, and you can have your data stored and still access it from your application. So you can still have your data stored with SingleStore and access it within your application, even if it's not in Python. Yeah, definitely.
So we have the like just to close off, we have like same guy. It's like a philosophical question from the same person, Vesaki. Would you think that the assistant will replace the doctor one day? What's your comment on this?
Yeah, so that's a great question. And that goes to back to our upcoming research, M3 help. Um, so I don't think this is my personal opinion. I don't think the assistant will replace the doctor. there's a lot of things that you have to consider about the assistant having, and it's not just having medical information and medical data. You need it to be ethical. You need it to be kind of empathetic. You need it to have emotion. Doctors contain not just all of that information, but the way they deliver your diagnosis to you, the way they comfort you. There's a lot of other things that are needed as well, in terms of understanding and just kind of diagnosing the patient. Other than that, also in terms of diagnosing, the doctor understanding the kind of demographic and the user's environment, and just better able to help and diagnose the user with the information from M3 Help. But you also kind of need to understand its accuracy, especially at the different levels here, to be able to determine whether to go with this or go with this. And that judgment call, I would say, would go for the doctor there. Yeah, so the answer is,
Right.
for now, at least, I would say no.
Right. So, all right, we can wrap up the session because we're almost at the top of the hour. I'm very sorry if we have not been able to take up your question. Vinija, can we please go to the slides, the wrap-up slides? I think I have they might, can we just go to the slides we went to initially? Yeah. So, all right. Thank you so much, Vinija, and thank you everyone for attending. You did a tremendous job, Vinija, with the demo. Thank you so much. This was very interesting. So, just a small just quick notes before I announce today's raffle winner. We have got amazing sessions that are coming up. Can you please go to slide 3? So it's just coming over the next few days. On June 18th, we have, which is tomorrow, by the way, we have LLMs for Web Analytics, chat with your data. On June 19th, day after that, step-by-step guide to real-time PLG segment with segment and SingleStore. And on June 26th, unfreeze your iceberg data, real-time AI. If any of these topics are interesting to you, please RSVP right now. I'll see you all there. So the announcement that everyone's been waiting for. So after a random selection, the today's raffle winner goes to Senat Palisa Slamovic. He's the head of technology at Nokia Enterprise Office of CT. Congratulations and thanks for joining, sir. And if this is not you, Vinisha, can you please go to slide 5? If this is not you, thanks for joining. And just don't give up. We are going to announce one more AirPods and Meta Ray-Bans winner by the end of the day. For anyone who has tried out today's demo, the chances are high. So sign up at the link that is present on your screen and be eligible and be entered to win. I really thank you, Vinija, for your presentation today and the demo. Thanks everyone for joining. Good evening, good morning, good night, wherever you are, and have a great rest of the day. Take care, everyone. Bye-bye.
Thanks, everyone.
Bye.